Hi everyone, and welcome to Thursday's maths lesson on adding mixed numbers. So just remember this is an example of an improper fraction. So where the numerator is bigger than the denominator, the number on the top is bigger than the number on the bottom. This is an example of a mixed number. They are equivalent. So we have our whole with our fraction. This is the mixed number, improper fraction, proper fraction where the numerator is smaller. Number on bottom, the denominator. Okay, so we've got our recap questions. We've got 3 of these. So you need to decide whether A, B, C or D is the right answer. So which diagram does not show 3/5 shaded blue? So A, B, C or D. Pause the video and decide which one. Right, so the answer is D. So I'll talk about A and B first, and then we'll talk about these two. So remember, fractions are equal parts of a whole. So equal parts. So we have equal parts here. We have 5 equal parts, and 3 out of the 5 are shaded. So this is 3/5. Here we have equal parts, they're all the same size, and we have 3 out of the 5 shaded. So 3/5, 3/5. Here we have equal parts, there are 10 of them, and 6 are shaded. There's 2 different ways of looking at this. As we know, we can make this into equivalent fraction. So 10 to make that into fifths. 10 divided by 2 is 5. Where we use the bottom, we use the top. 6 divided by 2 is 3. So this is equivalent to 3/5. 3/5 also means 3 out of every 5. So here, at the top, we have 5 parts, and we have 1, 2, 3 shaded out of 5. And here we have 5 parts. So 1, 2, 3 shaded out of 5. So that is also worth 3/5. This one is 3 parts out of 5 shaded. However, they are not equal. So this is not 3/5 as a fraction. That's just 3 different sized areas shaded in. So this is not 3/5. Okay, next question. Which fraction is equivalent to 6/13ths? Is it A, 18/39ths, B, 1/2, C, 7/14ths, D, 5/12ths. So you need to be able to convert this fraction to one of these. Remember that whatever you do to the bottom, you do to the top. So if you times the top by 2, you have to times the bottom by 2. Okay, so the answer you should have got is A, because can we get to 39 for 13? We can get there by doing times 3. And if 6 times 3 is 18, then it works. And it is, because 6 times 3 is indeed 18. So 6/13ths is equal to, or of the same value as 18/39ths. We can't get this because to get from 6 to 1, you have to divide by 6. 13 divided by 6 is not 2. To get from 6 to 7, you can't do that. To get from 6 to 5, you can't do that. So those don't work. It has to be A. Right, last one. What improper fraction is shown on the number line? Oh, that's going to be mixed. I suppose it's going to convert it to. Oh, difficult one. So what is shown on the number line? 2.6. It can't be that because that's a decimal. I won't tell you that. So A, 2.6, B, 2 3/5, C, 2 3/4, D, 13/5. So pause the video and have a go at that one. Right, okay, I did kind of give a little bit away when I went through it. So that's a decimal, so it's not a fraction. You could convert that into a mixed number, which would be that, but that's not how it's written, that's decimal, so it's not that. So we need to work out what these gaps are. So we've got 5, 1, 2, 3, 4, 5 gaps. So it's 1, 2, 3, 4, 5, because it's 5 gaps we are working in fifths. So that's going to be 2 and 1/5, 2 2/5, 2 and 3/5, 2 and 4/5, and 2 and 5/5 is 3, isn't it? Because 5/5 is a whole. Okay, so that, if I wasn't paying attention to the question, would point to this being the answer. It's certainly not that one. It's not quarters, is it? However, if you look at the question, it says improper fraction. That is not an improper fraction. 2 and 3/5 as an improper fraction. So we've got 2 wholes, so 2 times 5, which is 10. Add the 3/5 you already had, it's 13. So the answer is D. You might have figured that out right at the start, because that's the only improper fraction that you are given. So as a mixed number, it's 2 and 3/5. It's a decimal, it's 2.6. Don't worry about that. That's not something we've looked at all, but just for your information, is 2.6. And as an improper fraction, it's 13/5. Okay, so we have 5 numbers here. Might be mixed numbers, there might be improper fractions, it might be proper fractions. And we have match each number to a description. Each number can be matched with more than one description. So we're going to look at this one. Well, we can pause the video and do it for all of those, but we have non-unit fraction. Remember, if the numerator is not a 1, then it is a non-unit fraction. We have an improper fraction where the numerator is bigger than the denominator, less than 1, greater than 1. Unit fraction where the numerator equals 1. Proper fraction where the numerator is less than the denominator. Mixed number where you've got your whole and your fraction together. And incorrectly written is something that shouldn't be written that way. So pause the video and see which descriptions you match up with these. And remember, it can be more than one. Right, let's look at 1/3 first. So 1/3 is a unit fraction because the numerator is a 1. It is a proper fraction because the numerator is less than the denominator. And it is less than 1 because 3/3 is 1. Let's get 9/2. So that is an improper fraction because the numerator is bigger than the denominator. It is a non-unit fraction because the numerator is not 1, and it is greater than 1 because 2/2 is the same as 1 and it's more than that. Let's look at 2 and 8/3. So that is greater than 1 because it's got 2 wholes. It's also incorrectly written. If you have a mixed number, it has to be integers, so whole numbers, with proper fractions, because 8/3 is actually equivalent to 2 and 2/3, isn't it? So that would actually be written 4 and 2/3. So that is incorrect because you don't leave an improper fraction as part of your mixed number. Oh, stand for me. Right, next one, 4/7. That is less than 1. It is a proper fraction because the numerator is less than the denominator. It is a non-unit fraction because the numerator does not equal to 1. So then we have 7 and 2/5. This is something that is greater than 1, and it is a mixed number. So well done if you got those. Okay, so we're adding mixed numbers today. We're going to look at a couple of different approaches here. So we have 2 and 1/5 plus 3 and 3/5. So this girl is saying, I'm going to convert both mixed numbers to improper fractions first. So this is her method and it is a method that works. Then we're going to see a different method and see which one you prefer. Okay, so 2 and 1/5. So 2 wholes and 1/5. So you've got 2 lots of 5/5. Yeah, plus 1/5, which is 11/5. And then 3 and 3/5, we visualize that. We've got 3 wholes and 3/5. So 3 lots of 5/5 plus 3/5 is 18/5. So you're doing 11/5 add 18/5, which is 29/5. And then if you convert that into a mixed number, how many 5s? In 29, you're going to get 5 holes with 4/5 left over. So that is one approach for that question. So same question, different approach. I'm going to add my whole numbers and fractions separately. So here we have it drawn out, 2 1/5 and 3 3/5. So we're going to add our holes. So 2 add 3. So separating these, so we're doing 2 add 3, which is this bit here. 2 holes add 3 holes. And then we're doing 1/5, 3/5 over here. So 2 add 3, which is 5, and 1/5, 3/5 equals 4/5. So which method do you prefer? I think that the easiest way is most definitely this chap. So if you add your whole numbers first and then your fractions, there's less converting that you need to do. If you like it the other way, it's absolutely fine, but I'm going to suggest you do it his way today. Right, so here we have 3 1/4 plus 4 and 5/12. Ooh, we've still got that there. Denominators need to be the same, don't they? Okay, so we're going to add our wholes. So 3 plus 4, which is 7. Easy. 3 plus 4 is 7. Cross those out now. Done them. 1/4 and 5/12. Okay, we need the denominators to be the same. So we need to make our quarters into 12ths. What do you do here? So 4 times 3 will give you 12. So you need to do 1 times 3. So it's going to be 3/12 plus 5/12. Which equals 8/12. So 7 and 8/12. You will notice that. So this is an acceptable answer. But we can simplify that. We'll notice that they're both in the 4 times table. And 8 divided by 4, where we use the top, use the bottom, 12 divided by 4. It's going to be 7 and 3/4. Okay, so have a go at questions 1 to 4 on the worksheet. Remember to add those whole numbers first and then add the fractions, making sure those denominators are the same before you add them. Right, so here we have a shape. Do you know what the shape is? It is a rectangle. 2, which is 2 1/4. 2 1/4, 2 1/15 of a metre. In this rectangle, each longer side is 1 4/5 of a metre longer than each shorter side. So we have the length for the shorter side here, which is 2 1/15 metres, and each longer side is 1 4/5 of a metre longer than each shorter side. What is the perimeter of the rectangle? So remember what you know about rectangles. So if you know this length, what else do you know? And then how are we going to work out these ones? Okay, so if you know this one is 2 1/15 of a metre, then this one has to be the same, 2 1/15 of a metre. In this rectangle, each longer side is 1 4/5 of a metre longer than each shorter side. So this side and this side are 2 1/15 of a metre plus 1 4/5 of a metre. 1 4/5, if I just show you that, so we need to make the fifths into 15ths to add them. 5 times 3 is 15. Where you do to the bottom, you do to the top. So 4 times 3 is 12/15. So we're doing 2 1/15 plus 1 and 12/15. So add those wholes. 2 plus 1 is 3. Add those fractions. 1 plus 12 is 13. So 3 3/15 of a metre. So we're pretty much there. However, we do need to add all of those together to get the perimeter. Because remember, the perimeter is the total length around the outside of the shape. We have to add those 4 fractions together. So 2 1/15 plus 2 1/15 plus 3 13/15 plus 3 13/15. So let's add those wholes. 2 add 2 is 4, add 3 is 7, add 3 is 10. Then we need to add our 15ths. So remember, the denominators stay the same, so it's going to be in 15ths. I'm going to write my answer here because I know it's going to appear to the right and I want this to stay here to show my working. So 1 add 1 is 2, add 13 is 15. Oh, might stop there actually. See if we can notice why. And then add another 13. So the eagle-eyed amongst you will notice that 15 15ths is a whole. So I can put that straight into my wholes. So it's going to be 10 plus 1 is 11, and 11 and 13 15ths. But 15 plus 13 is 28 15ths, which is the same as 11 and 13 15ths, which is what we worked out, because 1 add 1 add 13 is 15, 15 15ths is a whole, and you've got 13 15ths left over. Right, so great time to pause and have a go at questions 5 to 6 on the worksheet, then come back for the last question we're going to go through, I believe. Okay, so we have two mixed numbers here added together equals 7 and 3 somethings. So we're working in quarters and we're working in eighths. So we want, I'm just going to rush through this. Okay, so we're looking at different options that could go in there. So something and something. There's something wholes and something quarters. So these two added together is going to equal that. So if we make that, looks like you see the numbers that are underneath, but you're not supposed to. They're a bit misleading, so just ignore what you think you see underneath. So if we make that quarters, so 7 and 3/4, we know that 1 add 2 is 3. So that's right. And then we just have to have digits that add up to equal 7. So 5 add 2, 6 add 1, 3 add 4. We could swap them round. 6 add 1, 5 add 2, 3 and 4. So that's some options there. So just what wholes can you put in those spaces and what numerators can you put in to make 3. Sorry, those boxes are a little bit out of line. It makes it a little bit misleading because you're probably looking at it thinking, oh, that's an 8th. Oh, that's probably a 1. Oh, that's probably a 6. It doesn't quite work that way, unfortunately. Right, so we have 3 and something 6th plus something thirds equals something 6th equals 6 wholes. So let's think about that. Just make sure that's exactly the same. It is. Okay, so 6 wholes we know is 36 sixths because there are 6 sixths in a whole and there's 6 lots of that. If you multiply fractions, you only multiply the top, so 36 sixths. Then we've got the rest to work out. Okay, so we've got, could it be 3 wholes plus 3 wholes and the fractions? No, because we know our final answer is 6, and if we put 3 in there, we've got 3 and 3, and then we've got fractions to add as well. So it cannot be 3, it has to be less than 3. So if trial and error here, put a 2 in. So 3 plus 2 equals 5. So then we need how many sixths add how many thirds equals 1 whole, because we still need to make up 1 whole to get from 5 to 6. So something sixths plus something thirds equals 1. So if we had 1/3, how many sixths you add to 1/3? I'm just going to write here, what is 1/3 in sixths? 3 times 2 is 6. What we do to the bottom, we do to the top. So 2 sixths is the same as 1/6. To get to 6 sixths, which is a whole, I need to add 4 sixths. So that has to be 4 sixths. So an option could be 3 and 4 sixths plus 2 and 1/3, which is 36 sixths, which is 6 wholes. Okay. So your activity has been assigned to you on Teams, and the question sheets are all sent to you on Monday on Tapestry. So have a go at those, check your answers against them. If you get some wrong and you can't figure out why, then come to the feedback sessions and ask your questions, and I will go through them with you. Thank you very much for listening, and speak to you soon. Bye.